If y equals f of x, which equals 3 to the x, find x equals f inverse of y. Notice there's no switching of variables required in this problem. This is good practice for when we're working an application problem where it doesn't make sense to switch the variables because the variables would have specific meanings. So I'm going to start with my exponential equation, y equals 3 to the x. I need to solve this equation for x. I can do that by switching from exponential form to logarithmic form. I have a base 3 exponential, so my logarithm is going to be base 3. I have log base 3 of y equals x. Remember that a logarithm is always equal to the exponent, and in this case, our exponent was x. So we have x equals f inverse of y, which equals log base 3 of y. We can verify this graphically. Let's pull up our graphing calculator. In y1, I'm going to plot 3 to the x. In y2, I want to plot my logarithmic function. There's a couple of things I have to remember here, though. First, on a graphing calculator, y always has to be written as a function of x. So I am actually going to have to switch variables to graph this. I want to graph y2 equals log base 3 of x. The other thing to remember is that our calculator doesn't have a base 3 logarithm. It's easy to find the natural logarithm. It's right above the x key here. I can use the change of base formula to change log base 3 of x to a natural logarithm. Log base 3 of x is the same as natural log of x divided by natural log of 3. So let's plot that. Natural log of x divided by natural log of 3. Now there's one more thing I want to plot here. A function and its inverse should be reflections about the line y equals x. So I'm going to plot y3 equals x. Now let's graph all three of these. Right away I can see the line y equals x, which goes through the origin. And then I can see the exponential function above the line here, and the logarithmic function below the line here. Now let's test a couple of points to make sure that if we look at an x and y coordinate on one graph, we get those values switched around on the other graph. So for instance, if I put x equals 1 in on the exponential function, let's see what my y coordinate is. 3, that makes sense. 3 to the first power is 3. So on my log graph, if I put in an x coordinate of 3, I should get a y coordinate of 1. Right now we're on graph 1. y1, remember, was the exponential. y2 was the log. So let's move down to our second graph and put in 3 for x. Hopefully my y coordinate here is going to be 1. And indeed, there it is. The point 31 is on the log function. Let's put in another value on my exponential. So back up to the first graph. What if I put in -1? The y coordinate looks like 0.33333333, or in other words, 1/3. That makes sense. 3 to the -1 is 1/3. So if I put in an x coordinate of 1/3 on the log function, I should get a y coordinate of -1. Let's verify. So down to y2, my log function, if I put in 1/3 for my x coordinate, let's see what the y coordinate is. -1, as it should be. So it looks like we have a pretty good idea that these really are inverse functions, verified by our graphs here. So if y equals f of x equals 3 to the x, then x equals f inverse of y is log base 3 of y. Remember, exponential functions and log functions are inverses of one another.